Have you ever gazed up at the night sky and wondered why stars have different colors? Stars, those glittering celestial orbs, are not just white spots scattered across the inky black canvas of the sky. They come in a palette of colors: blue, white, yellow, red, and more. This colorful display isn't just for our visual pleasure. It tells us something fundamental about the stars themselves. The color of a star is a direct clue to its temperature. Much like a metal rod, heated until it glows, stars too emit colors based on how hot they are. The hottest of stars blaze with a blue or white hue, their intense heat mirrored in their brilliant radiance. On the cooler end of the spectrum lie the red and orange stars. Their lower temperatures result in a softer, warmer glow. So, when we look up at the stars, their colors are painting a picture of their temperatures. But how exactly does a star's temperature determine its color? You might wonder. Well, let's take a journey into the world of physics, specifically to the concept of black body radiation. This principle explains why objects change color as they heat up. Imagine you're heating a piece of iron. At first, it remains its normal color, but as it gets hotter, it begins to glow red. Increase the heat and it will turn orange, then yellow, and finally white. What's happening here is that the iron is becoming a black body radiator, an object that absorbs all incoming light and re-emits it based on its temperature. Now let's apply this concept to stars. Just like our piece of iron, stars too emit light based on their temperature. The only difference is that stars are much hotter than any iron piece could ever be. So, when a star is relatively cool, it emits light at longer wavelengths, which we perceive as red. This is why cooler stars, like Betelgeuse in the constellation Orion, appear red to us. As a star's temperature increases, it starts to emit light at shorter wavelengths. If it's a bit hotter than our sun, it may appear white, like Sirius, the brightest star in our night sky. But what about stars that are really hot? Well, these stars emit light at even shorter wavelengths, which we perceive as blue. Rigel, also in Orion, is a blue supergiant and one of the hottest stars visible to the naked eye. And what about our own sun? Well, our sun is a medium-temperature star, which means it emits light at a wavelength we perceive as yellow. So, the color of a star isn't just a pretty sight. It's a direct indicator of a star's temperature, telling us whether it's relatively cool, like a red dwarf, or super hot, like a blue supergiant. And there you have it. The color of a star is a direct reflection of its temperature. Now that we know why stars have different colors, what can these colors tell us? Well, the color of a star is like a window into its life story, providing clues about its age and stage of life. Younger stars, for instance, are often hotter and emit a blue light. Their intense heat is a sign of their youth and energy. As they age, stars cool down and their color shifts from blue to white and eventually to red. This transition to red is a clear indication of a star's advancing age and decrease in temperature. Astronomers, like celestial detectives, use this color information to map the life cycle of stars. The color of a star can help them determine whether it's a youngster in the stellar neighborhood or a wise old star nearing the end of its journey. So, not only are star colors beautiful, they also offer a glimpse into the life story of stars. Let's quickly recap what we've learned about star colors. The hues that paint our night sky are not random. They are, in fact, cosmic clues that reveal significant information about the stars themselves. The color of a star is primarily determined by its temperature. Hotter stars glow bluish-white, while cooler stars emit a reddish light. This is due to a phenomenon known as black body radiation, where the color of the light emitted depends on the object's temperature. But there's more to the story. The color of a star also provides valuable information about its age and life stage. For instance, red giants are older stars nearing the end of their life cycle, while white dwarfs are remnants of stars that have exhausted their nuclear fuel. So, the next time you look up at the night sky, remember, the colors you see are telling a story of temperature, age, and life cycles written in the stars.